Hello everyone, am I audible?
Yes, sir.
Everyone is okay? Revised everything? Good evening, Ronaldo. Everyone is completed with application of derivatives?
Good evening, sir.
Good evening, Krishna. Ishan, Krishna, Shikani, done with application of derivative?
Yes, sir.
And rest of you, Kulsum, Said, Ronaldo? All right, anybody has any doubts of that chapter? That is a very important chapter. All right, so I am hoping no doubts. We are starting integration today. This is also very important, because if you don't understand this chapter, you will not be understanding coming two chapters. All right, area under curve.
Sir, I have a
differential
doubt in
equation.
the previous chapter, sir.
All right,
So, for finding maximum, minima, like, can we use any of the method, either the first derivative and the second derivative?
yes, you can use any of the methods.
Okay.
Any more doubts? Any questions you could not solve?
No, sir.
All right. So integration is very important, and most people think this is difficult, and yes, this is difficult. Why it is difficult? You are going to need everything we have learned from like since child in this chapter, right? Every formula, every identity, everything. Which formula I'm talking about? A plus b whole square, a minus b whole square, a plus b whole cube, a cube minus b cube, a cube plus b cube. Every formula of trigonometry, everything. That is why this becomes a little bit difficult. Most of the reason is trigonometry. All right, so that thing I have been telling since class 1, that please revise trigonometry, please revise trigonometry. All right, I'm hoping everyone remembers all the formulas till by now. All right, if not, then again please, after the class, Google all the trigonometry formulas of class 11, memorize that like it's your name. All right, otherwise you will not be able to solve most of the questions. This thing is clear, everyone?
Yes, sir.
All right, Shikani, Ishan,
Yes,
clear?
sir.
Yes, sir.
Said, Kulsum, Ronaldo?
Yes, sir. Yes, sir.
All right. This is the first advice. Second advice or second note, I can say, the faster you are able to differentiate things, the faster you will be to solve integration questions. What I mean by this? Ishan, can you tell me what is the differentiation of tan inverse x? Shikani, what is the differentiation of tan inverse x?
1 minute, sir.
No, all right. Krishna? Kulsum? Said, what is the differentiation of tan inverse x?
1 by 1 plus x square.
Yes, 1 by 1 plus x. See, this is the problem why integration is difficult for most of the students. If you miss these things, this is direct formula. If you are not able to even differentiate things, then you will not be able to integrate anything. Take my words for this. you have to solve as many questions of differentiation to be good at integration. All right, I asked 5 students, 4 of you could not tell me the answer. Right, this is the direct formula of differentiation. Right, Kulsum, Krishna, Shikani, Ishan.
Yes, sir.
So please, this is the second advice, second note, please be really good at differentiation. Memorize all the formulas. All right, integration is of 3 chapters. It weighs a lot of marks. And if you want to be really good, be better at differentiation also. Right. So this is 2 tips. If you are doing these 2 clear, then no issues you will be having in integration. If you don't know this thing, then I cannot make you understand integration at all. Right, that is out of my power. I'm not God. All right. So integration, what is integration? First of all, there are 2 types of integration we are going to study. First is indefinite and definite. What is indefinite integration? Where we are not talking about limits, from where to where we are integrating things. In definite integration, we will talk integrate from this to this. All right, let me explain in some other way. What differentiation does, if you have a graph, differentiation breaks things down, right? Finding the slope, finding maximum minimum. What is integration? Integration is just the opposite of that. Integration joins things, makes things whole. Differentiation breaks things, and integration joins things. Just the reverse process of differentiation. That is why I'm saying differentiation is very important to learn integration. This is the complete opposite. Even the definition of integration is that. What is integration? The antiderivative of a function or opposite of differentiation. That is integration. What this means? In this previous example, I differentiated tan inverse x with respect to x. We got 1 upon 1 plus x square. So what is integration? What function do you have to differentiate to get this as the result? How do we write integration? This is the symbol like this, f of x dx. This is integral sign. All right, just a symbol to represent integration, like d upon dx is differentiation. This snake-like symbol is integration, s-like symbol. F of x, this is called integrand, the function you have to integrate. What is dx? Differential. With which respect to you, like you want to integrate. Here you want to differentiate with respect to x, here you want to integrate with respect to x. All right, dx, differential of x. You want to integrate with respect to x. That means f of x should also be in terms of x. All right, this symbols is clear how to write these things. Function dx, and then this is integral symbol, integral sign. This thing is clear, everyone?
Yes, sir.
Please note it down, these things.
Sir, what is the third last word of the definition?
Third last word of differentiation. Opposite of differentiation is integration. Done, everyone?
Done, sir.
All right. So what does it mean? This means, very simple terms, if I write differentiation of sine x, what is differentiation of sine x?
Cos x.
Cosec.
Cos x. Absolutely right. So if this symbol goes to this side, this becomes integration sign. Integration of cos x dx will be equals to
Sin x.
sine x. Very simple. If differentiation of sine x is cos x, then what function will we get to integrate cos x? Sine x. Right? Just the opposite, reverse process. All right. But remember one thing, there will be a constant of integration here. This is called constant of integration. All right. What is constant of integration? Suppose I take sine x plus 3. What is the differentiation of this function?
Cos x.
Cos x. If I write sine x plus 4,
Cos x.
cos x. Sine x plus 5,
Cos x.
cos x. So you get what I'm saying? If you add any constant to any function, sine x plus c, differentiation removes this constant, makes it 0. So we cannot tell which was the constant here. So we write or add a constant here and we leave it as it is, like c plus c, sine x plus c. All right. This thing is clear.
Yes, sir.
Everyone, do not forget the c sign. They will cut your half marks and you will forget the c signs. So make a habit of writing the c sign always. All right, everyone, please note it down. This c is called constant of integration.
Done, sir.
All right. So we have to write down few formulas of integration also. You have to memorize this. Otherwise, very difficult to solve. All right. So first, let's write differentiation. And this is integration. Differentiation of x raised to the power n plus 1. This x, this is n upon n plus 1. Who can tell me differentiation of x raised to the power n plus 1 upon n plus 1?
Or x raised to n.
X raised to the power n. Absolutely right. Who could not differentiate this? Ronaldo, that is not the right answer. Right, power comes before, then power minus 1. So this n plus 1, n plus 1 will be cancelled. X raised to the power n remains. See, if you don't know differentiation, no point. All right, so please revise. All right, Ronaldo. So integration of x raised to the power n, what we will write?
X power n plus 1 by n plus 2.
Yes. Plus c also. Right, Krishna? Do not
Yes,
forget
sir.
the c. C carries half marks with it. Differentiation of sin x. Differentiation of sin x.
Cos x.
Cos x. So integration of cos x will be
Sin x. Plus c.
c plus c. Right. Differentiation of minus cos x.
Sin x.
Sin x. So integration of sin x will be
Minus cos x plus c.
differentiation of tan x.
Sec square x.
So integration of sec square x.
Tan x plus c.
Differentiation of minus cot x.
Cos x for x.
Cos x square x. So integration of cos x square x. Integration of cos x square x
Minus cot x.
plus c. All right, please note it down. Then I'll change the page. Done, everyone?
Done, sir.
All right. Sixth one, differentiation of sec x. What is differentiation of sec x?
Sec x tan x.
So what will be integration of sec x tan x?
Sec x.
Plus c. Do not forget plus c. Differentiation of minus cosec x.
Cosec x cot x.
Absolutely right. So integration of cosec x cot x.
Minus cosec x plus c.
Absolutely. Who else remains? Differentiation of e raised to the power x.
E power x.
So integration of e raised to the power x is
E power x.
plus c. And differentiation of sine inverse x.
1 by root 1 minus x.
Square. 1 minus x square. So integration of 1 upon under root 1 minus x square is sine inverse x plus c. Differentiation of cos inverse x.
Minus 1 by root 1 minus x square.
So integration of minus 1 upon 1 minus x square will be
Cos inverse x. Plus c.
plus c. Yes, plus c. Don't forget plus c. Tan inverse we did not write. So tan inverse x
1 by 1 plus x square.
So integration of 1 by 1 plus x square is
Tan inverse x.
plus c. Differentiation of log x
1 by x.
and integration of 1 by x. This, please remember this. 1 by x is log of mod x.
Plus C.
But here plus c. Absolutely right, Shegani. So do not forget this plus c and this mod x, log of mod x. Okay. Note it down. And you guys can write all the inverse trigonometric formulas also. You don't need to write all of them. You guys remember the formula, then it is okay. Write it down. And here also notice one thing. Sometimes you will be confused by this. If I take this negative sign to this side, then 9 and 10 become the same result also, sine inverse x and minus cos inverse x. So never be confused about that. All right, you can write any of that, no issues. All right. Is it clear what I said?
So I didn't get it. Like, can we write as minus cot x minus c?
This is cos. Okay, this is cos. See, if I take this negative sign to this side, there will be no issue, right? If I just write like this, right, Krishna?
Yes, sir.
So here you can like see 9th and 10th, 1 upon 1 minus x square under root, 1 upon 1 minus x square under root. The same integration becomes different answers. So two things, never be like confused by your answer. Integration can result in many answers, but most of the questions will be solving, will try to get the answer that is matching with the NCRT. All right, but if you get a different answer, don't worry. All right.
So minus won't affect the plus C.
No, that will not affect C. C, we have not put any specific value, right? So if you write minus C, and I will say that minus C becomes plus C2, and this is same thing, right? We have not told what is the value of C. This thing is clear, Krishna, or
Yes,
should I explain? Okay. Noted.
Done, sir.
All right. Few more formulas. These formulas you have already like memorized in differentiation, I believe. At least I believe that. I don't know if that is right. Differentiation of cot inverse.
Minus 1 by 1 plus x square.
So integration of 1 by 1 plus x square, we can write minus cot inverse x plus c. Differentiation of sec inverse x.
1 by mod x root x square minus 1.
differentiation of cosec inverse x.
-1 by mod x to x square minus 1.
What remains? Log formula, last one. Differentiation of a raised to the power x upon log a is a raised to the power x. So integration of a raised to the power x is a raised to the power x upon log a. Okay, very important formula. Students tend to forget this one, this log a, but please remember this. When you integrate a to the power x, that means 3 to the power x, 4 to the power x, any constant to the x, then integration will be a to the power x upon log a. All right, everyone?
Yes, sir.
Note it down. Then we'll solve few questions.
Done, sir.
All right. So please memorize this formula by next class. Few things to note before we solve integration questions. Very simple things. If there are two functions added in integration or subtracted, then you can break this down. All right. This thing you can do very easily. Do not do this in multiplication or division. If two functions are added or subtracted, then you can break down. If multiplied, then we'll see how to different questions. Our main focus when solving question of integration is to bring all the functions in this 16 form. There is no other thing you need to know. The rest of the chapter is to how to bring all the questions in the standard formula. That is all the tricks we are going to learn. All right, formula will not change. Formula are these 16 only. This thing is clear, everyone?
Yes, sir.
Yes, sir.
So now on, our only goal is to bring all the functions in these 16 forms that we already know the formula of. All right. So first question, x to the power 4 dx. Which formula are we going to use in this?
16th.
16th formula. This is
X
a raised
raised
to the
to
power
n.
x raised to the power n, right? Krishna, this is a raised to the power x, 3 raised to the power x exponential function. This is polynomial function, right? X raised to the
Yes,
power
sir.
4.
Yes, sir.
So this formula is integration of x raised to the power n. Who can tell me what is the formula?
X
X
raised
power
to
n
n plus 1 by n plus.
Right. So this will be x raised to the power 5 upon 5 plus c. This thing is clear, everyone? Add 1 to the power and divide by that power plus c. This thing is clear.
Yes, sir.
All right. These things you must have done in physics also, right? Basic integration. Yes or no, everyone?
Yes, sir.
So please solve this. X to the power 3 dx. Let's make it minus 3. Third, x raised to the power minus 10 dx. Fourth one, 1 upon x raised to the power 4 dx. All right. 3 questions for you. I'll give you a few minutes. All right. Kulsum, Said, or Said has sent the answer. Kulsum, Ronaldo, Ishan, Shikani. Have you solved this? All right. Kulsum, what about you? Just a second. All right. Ishan, Shikani.
So let's solve until the third question.
So the third question. All right. Shikani? Select the first one. This is, please match your answer. This is x raised to the power minus 2 upon minus 2 plus c. This is x raised to the power minus 9 upon minus 9 plus c. This we can write integration of x raised to the power minus 4 dx. So this is x raised to the power minus 3 upon minus 3 plus c. All right. Please match your answers. Solve this one. Integration of x raised to the power minus 1 dx. Tell me what you get. All right. Ronaldo, what is x raised to the power 0 upon 0? Can we have 0 in the denominator? No. And how to solve this? This is just to confuse you guys. This is nothing more than, this is integration of 1 upon x dx. This is standard formula. 1 upon x is log of mod x plus c. All right, everyone.
Sir, how did you get 1 by x?
X to the power minus 1 is 1 by x, right?
Okay, sir.
X.
Okay, sir.
All right. Next question. So they will do this kind of things to confuse you. You don't have to worry. Just remember all the 16 formulas. That's all. We will not, what they say, hilna nahi on solar formulas. Sixth question. Integration of sin x plus cos x dx. Please try to solve this. All right. The right answer. Ishan, have you solved this? Kulsum, your answer is 2. Ishan, I told you, see, you can break this functions, right? Addition. So we can write this integration of sine x dx, this integration of cos x dx, right?
Yes, sir.
So what is the integration of sine x?
So cos x.
Look at the formula again.
Sorry, sir, that too was a typo. That's not the answer.
All right. All right. Ishan, what is the integration of sine x? You wrote the formula. Look at your notes. Correct answer, Kulsum, Ronaldo. Ishan, you got the formula?
Yes, sir. Minus cos x plus c.
Yes. So minus cos x plus c plus integration of cos x is
So sin x.
sin x plus c. So what we can do here is add this c, this 2c, and write is as 1. So sin x minus cos x plus c. All right. Because we don't know the values of this c, so they will be added together. Two numbers can be added together and represented by third letter. All right.
Okay, sir.
All right. Next question. I hope this is being clear to everyone. Very important. This will teach you how to solve things. So we are just trying to manipulate all the functions into what we already know. Please integrate this. All right, Krishna. Any ideas how we can solve this? Said you missed one thing. Let's see. If we just open these brackets, what we'll have? This is x cube minus x cube upon x cube dx. Right, Ishan? This is clear? Ishan, Shikani, this is clear. I just opened the brackets. So this we can write x cube minus 1 dx. Now, if we break this down, then we'll have integration of x cube dx minus integration of 1 dx. So what is integration of 1 dx? This is x raised to the power 4 upon 4 minus integration of 1. 1 we can write x raised to the power 0. So this will be x raised to the power 1 upon 1, which is x plus c. So remember, any integration of any constant into dx is constant into x. So integration of 5 dx is 5x. Integration of 6 dx is 6x. Integration of dx is x. All right, everyone? Yes or no, this thing is clear or not?
Yes, sir.
All right, note it down. Next question.
So what about integration of constant?
Integration of 5 dx. This is constant, right? So this
Yes,
you
sir.
can write 5 into x raised to the power 0 dx, and you can take 5 outside of integration also. You can take constant outside of integration. So this is 5 integration x raised to the 0 is x plus c. All right,
Okay, sir.
note it down. Ax square plus bx plus c dx. Integrate this one. Yes, Sonal, the A, B, C, and are constant. All right, let's see. Again, we can break this down. This is integration of ax square dx plus integration of bx dx plus integration of c dx. So integration of a is outside constant. Integration of x, so x to the power 3 upon 3 plus b outside. Integration of x is x square by 2 plus c is cx and plus c2 we can write already. C is already there, so we can write c, del c, whatever you wish, no worry. Absolutely correct answer. All right, Ishan, this is clear.
Yes, sir.
Kulsum, this is clear. Sorry,
This is the final answer.
yes, this is the final answer. Kulsum, Shikani, this is clear.
Yes, sir.
All right, next question, note it down. Integration of 2x square plus e to the power x dx. All right,
Sir, and 8th question, where did the C2 come from at the end?
that is the constant of integration. Instead of writing c, because I already have c here, so that there is no confusion, I can write c2. This is constant of integration, right? Sin x plus c cos x, that c is I wrote as c2. All right, or c1 we can write. All right, no worries. Right, this question is also very simple. Just take this down. Integration of 2x square dx plus integration of ex dx. This is 2 outside. X square is x to the power 3 by 3 plus e to the power x is e to the power x, and this is plus 3. So final answer 2 by 3 x to the power 3 plus e to the power x plus c. All right, clear everyone?
Yes, sir.
All right. Note it down. Who has not solved this? Rest of you, please solve this question. Integration of root x minus 1 upon root x whole square dx. All right. What you can do here, you can just use a minus b whole square and you'll get the answer. So integration of root x square plus 1 by root x square minus 2 into a into b into dx. So this is integration of root x whole square is x dx plus integration of 1 upon x dx minus integration of 2 dx. So this is x square by 2 plus log of mod x minus 2 x plus c. Everyone is clear about this? Ishan, Shikani, Krishna?
Yes, sir.
All right. Ishan, this is clear?
Yes, sir.
All right, note it down. Next question. Integration of x square plus 5x cube minus 4 upon x square dx. All right, try to solve this one. I need everyone's answer in this. All right, I'll give you a hint. Just divide this x square with each part, then integrate separately. All right, everyone. I need everyone's answer in this question. Kulsum, Ronaldo, Ishan, Shikani, I need your answer in this. All right, let's see. We can simply divide this x square upon x square plus 5x cube upon x square minus 4 upon x square times dx. This is integration of dx plus integration of 5x minus integration of 4 upon x square dx. Very simple. This is integration of x plus this is 5x square by 2 minus this is 4x to the power minus 2 integration. All right, x to the power minus 2 integration, which is x to the power minus 1 upon minus 1. So this, let me write this, minus 1 upon minus 1 dx. So this minus minus becomes plus. So x plus 5x square by 2 plus 4 upon x. Why am I writing dx? Plus c. All right, everyone. Ishan, this thing is clear?
Yes, sir.
Shikani?
Yes, sir.
All right, note it down the answer if you have not solved. Integration of x cube plus 3x plus 4 upon under root x dx. Everyone solve this?
Yes, sir.
Right, let's see. Again, we can divide this. This is x cube upon x to the power half plus 3 into x upon x to the power half plus 4 upon x to the power half and dx. So this is, if it goes to numerator, it becomes minus. So this will be x to the power 5 by 2 dx. Plus this will be 3 into x to the power by 2 dx. Plus this will be 4 into x to the power minus half dx. Integration sign here. So this is x to the power 5 by 2 plus 1. This is 7 by 2. So 7 by 2 plus 3 into x to the power half plus 1. So this is 3 by 2 plus 4 into x to the power half minus half plus 1 is half upon half. I hope this is clear to everyone. This is 2 by 7 x to the power 7 by 2. 3 and 3 is cancelled plus 2 into x to the power 3 by 2. 4. So this is 8 into x to the power half plus c. Let's match the answer. All right, Krishna, I think you have the correct answers. Said, I think you did a mistake there. All right,
Yes, sir.
everyone is clear about this? Kulsum, Ronaldo, Shikani, Ishan. Yes or no?
Yes, sir.
All right. Next question. Integration of x cube minus x square plus x minus 1 upon x minus 1. This. I'll give you one hint here. Try to factorize the numerator. Anyone solve this?
Yes, sir.
All right, Krishna, Syed got different answers. Let's see. This is integration of, if I take x square common, this will be x minus 1 plus 1 common x minus 1 upon x minus 1 in total multiplied by dx. So integration of taking x minus 1 common, x square plus 1 upon x minus 1 dx. This is cancelled. So what we got, integration of x square plus 1 dx. So break it down. This is x cubed by 3 plus x plus c. All right. Please everyone match the answer. Sayed, you wrote minus, but I think that is plus. All right. Note it down, everyone. Next question. Is it being clear or not, everyone?
Yes, sir.
All right. This is what basically integration is. Doing a lot of things to make this simple formula. Try to simplify this, answer this. All right. This is also very simple question. Just open this brackets. This is sec x into tan x plus sec square x, and this is dx. Break it down. Sec x into tan x dx plus integration of sec square x dx. Ishan, what is this formula? Integration of sec x tan x. Integration of sec x tan x. Shikani.
Sir, sec x plus c.
Sec x plus c, right? So this is sec x plus what is the integration of sec square x?
So tan plus c.
Right. So tan x plus c. So this is the answer. All right. So this is what simple integration is. All right, please note it down. If anyone has not, I'll give you a few minutes. All right. So integration in this class 12 is of three types or three methods we are going to learn. First is substitution, then partial fraction, and by parts. So I'll give you a quick introduction of substitution today. Whatever we did today is clear to all of you, I guess, right?
So what's the second one?
Partial fractions. Right? I'll explain everything, but today our focus is to get the intention of substitution. We'll solve questions in the next class. All right. How to see things, what to substitute. Always look for this. F of x, f dash x, and dx. What this means, if function and its differentiation multiply with dx, we'll always see questions based on this. Substitution is only applicable when you can see these things. If function and its differentiation, fx, f dash x, function and उसका differentiation. ठीक है, आंखें इसी को ढूंढनी चाहिए इंटीग्रेशन, फंक्शन उसका differentiation. This thing is clear to everyone?
Yes, sir.
Yes, sir.
Right? Function and f dash x. If you just got this, then substitution is complete. There is nothing else. Function, it's differentiation. So you always have to differentiate things. That is why I was saying differentiation is a must. If you cannot differentiate functions, then you cannot solve using substitution, which is the like gauntlet, infinity gauntlet, right? The most powerful things in the universe, in the integration universe. You cannot solve any questions. I don't know how many of you got the reference. All right. So let me give you a quick question example of this. If I write tan inverse x upon 1 plus x square dx. See, we know the integration of 1 upon 1 plus x square. We do not know the integration of tan inverse x. All right. So in this type of questions, while we cannot use the formula directly, what we have to look? We have to look for substitution, partial fraction, or by parts. First method is substitution. So can anybody see any function and its differentiation in this question? Function and its differentiation.
Yes, sir.
Which one is it?
Tan inverse x and 1 by 1 plus x square.
Absolutely right. So if f of x is tan inverse x, then we know f dash x is 1 upon 1 plus x square, and this 1 upon 1 plus x square is obviously multiplied with dx. Differentiation of the function will always be multiplied with dx. This is the tricks to note, what to assume. All right. So what we have to do? Substitute tan inverse x st, the function st. As simple as that. If as soon as you looked at this, that we have got tan inverse x differentiation is 1 upon 1 plus x square, assume tan inverse x is t, differentiate both sides. So what we'll get? 1 upon 1 plus x square dx, right? This, if I can write dx by dt, but always write like this, and this is dt. All right, this thing is clear. You can feel this like this. This is t. If I differentiate with respect to x both sides, this will be 1 upon 1 plus x square. This will be dt by dx. I threw this dx to this side, so this becomes this. This thing is clear, everyone?
Yes, sir.
So now substitute tan inverse x in place of this. So this I can write tan inverse x into dx upon 1 plus x. So tan inverse x, we have put t into dx upon 1 plus x square is dt. And if you remember, I told you this is called differential with what respect to you want to integrate. So here t and the function is also in t. So we can integrate this very easily. So integration of t dt is t square by 2 plus c. We can put the value of t again. So tan inverse x whole square by 2 plus c. How many of you understood this thing? How many of you did not?
I did not.
Sir, can we substitute directly as t and dt?
T and dt, I do not understand what you want to do.
The first two parts, right? We substitute tan inverse x is equal to t in that. Like
Right.
if we avoid that and we directly substitute tan inverse x is equal to t and write that, do we lose any marks?
Yes, it's better to show this thing, right? It will take just two steps, right, Krishna? And you will avoid making mistakes also, because all the questions will not be as simple as that. There will be constants also, so you have to write down the constant also. Or let's suppose we had 3 tan inverse x, so you had to write 3 here and throw this 3 to this side and so on, right? So it's better to always write this text. All right, Krishna,
Okay, sir.
everyone is clear about this method? Yes or no? Kulsum, Ronaldo, Ishan, Shikani, this thing is clear? All right. Half of you, your mics are not working. All right. So always look for function, its differentiation. Function, its differentiation. That is all substitution is about. All right. So we will solve few questions in the next class. Before that, I hope everything is clear about today. Remember, memorize all the formula. It must be like a river flowing, right? You should be that fast. Otherwise, you will not be able to solve or grasp integration. Right. So Monday, everyone must be remembering all the formulas of integration. All right. Solve the first exercise of NCRT, not first, second exercise, and we'll give you assignment also. All right, everyone.
Yes, sir.
All right. And in the next class, I'll be taking a test of AOD also. It was scheduled for Monday, but we'll keep it next week. AOD test on Monday. All right. This is all for today's class. You can leave.
So just a minute.
All right. Note it down.
Thank you, sir.
All right.
Thank you, sir.
All right.
Thank you, sir.
Thank you, sir.
Alright.
Salam.
All right.
Thank you, sir.
All right.